Hello and welcome to this lecture on the Service Manager in Zen Framework 2. So let's begin by talking about what the Service Manager is. Well, it implements the service locator pattern. So it's a central registry from which services, or you could say objects, are retrieved. So services are retrieved by a key, and you can call this anything you want. There are some conventions, but we'll get back to that later on. Keys must be unique across all modules, so services are stored within an array in the Service Manager class, and that's why the keys need to be unique globally within the application. Services are lazily instantiated when they are needed, and when you receive an object, you don't need to worry about instantiating it. The Service Manager has already done this for you. When you receive an object, its dependencies have already been resolved when you retrieved it from the Service Manager. So it's more than a key value registry as in Zen Framework 1. And I'll show you that it has a lot of features that are quite handy. First, a small disclaimer. The Service Manager is usually configured within a configuration file within each module, and the configuration is then merged by the module manager. The configuration files contain a PHP array, but in this presentation I'll use an imperative approach instead, because instead of including large arrays in this presentation, I'll use an object-oriented approach instead. This keeps everything more intuitive and it's easier to understand while discussing the theory. And this syntax corresponds very well to the normal syntax that you will use, so you won't have problems understanding the concepts. But just understand that this is not the common approach, but don't worry because we'll work with the normal approach later throughout the rest of this course. And also, just to keep things even more simple, I won't include namespaces in the service keys in this presentation. You would normally do this to ensure that there are no collisions, but to keep things simple, I will avoid this in this presentation. So now I'll give you a walkthrough of the different service types that you can use with the Service Manager in Zen Framework 2. First, we have invocables. An invocable is simply a string that contains a fully qualified class name, which is including the namespace. When you request an invocable, the Service Manager instantiates the class and simply returns the object. The way that you can add an invocable to the Service Manager is very easy. You can just call the setInvocable class method on the Service Manager, and first you provide a name for your service, and then you just provide the fully qualified class name, and that's it. Here we have an example of retrieving an invocable. So when you retrieve services, you don't need to know the type of the service that you are retrieving. An invocable is retrieved just like any other type of service. So if you look at the first example, we retrieve a service by calling the get method on the Service Manager, and we pass in the name of our service. In this case, we request a user service, and we'll get a fully instantiated object back, which is our user service. Internally, what happens within the Service Manager class, you can see at the bottom of this slide. You have a class name variable that just contains the fully qualified class name, and the Service Manager basically just instantiates this with the new keyword and returns the object. So the internal workings of the Service Manager in this case is super simple. Next up, we have factories. Factories are used to perform any setup or dependency injection that may be required for the requested object. So if you have an object that depends on another object, what you can do is you can inject this dependency by creating a factory. So a factory is either a PHP callable, an object, or a fully qualified class name. If we add the factory as an object or class name, we have a factory interface that must be implemented. This interface defines a create service method, and this method is invoked by the service manager. This method should return the object that we want to fetch. So basically we have a method or a function where you can write any code that we like that is responsible for returning the object that we want to return when we request an object through the service manager. Factories are mostly used if the fetched object has dependencies that need to be resolved. So here we have an example of adding as well as retrieving a factory. So in the first code snippet, you can see here that we call the setFactory method of the service manager class. As in the previous example, we provide a name for our service as the first thing, and then we provide a callable, in this case a closure, basically an anonymous function. As you might have noticed, this function takes one parameter, the service manager. This parameter is always passed to any callable, and this gives us access to the service manager so that we can use it to retrieve other dependencies that we need to inject into the object that we are fetching. So in this case, we're using the service manager to get our logger instance. And this logger instance is then used when we instantiate our user service. So as you see, this is actually an example of dependency injection, and this is something that you will see a lot in Zen Framework 2. The great thing about this is that fetching the service remains the same, as you can see at the bottom of the slide. So we don't need to worry about which kind of service we are retrieving or how the logic is implemented, if it's an invocable or factory or anything else. We just fetch it by name, and that's all. So we also have something called abstract factories. Basically what this is that it's a fallback in case a non-existing service is requested from the service manager. Attached abstract factory will be queried to see if one of them can return the requested service. These abstract factories that are added will be iterated upon, and it will be checked if either of them can retrieve the object that was requested. So there are two possible approaches. The first is a string representing a fully qualified class name, or we can add an object. In either case, the abstract factory interface must be implemented. This interface defines two methods. One is the canCreateServiceWithName method, and the other is the createServiceWithName. So as you can imagine, the first one returns a boolean indicating whether or not this abstract factory can create a service with this name. And the second one creates the service in case the former method returns true. Here we have an example of this. So here we have the method signatures of these two methods that we just discussed. So the first one determines whether or not the abstract factory can create a service with the provided name. And the createServiceWithName method is responsible for creating a service with a given name and returning it. So this is only invoked if the canCreateServiceWithName method returns true. We also have something called Initializers in Zen Framework 2. And this is a block of code that is to be executed when a service is retrieved from the service manager. This can either be a PHP callable, an object, or a string containing a fully qualified class name. If an object or string is used, then the class must implement the initializer interface. The newly created instance is passed and it can thus be manipulated. So when this function is run, whenever a service is retrieved from the service manager, this instance or service that is retrieved is passed as a parameter to our function. And this allows us to call, for example, setter methods on it or manipulate it in one way or another. This can sometimes replace factories. For instance, instead of injecting a database adapter into all of our database repositories, we might have a single initializer that can accomplish this, such that we don't have to write a factory for all of our repositories. We can just write a single initializer which checks that our service implements a given interface. And if it does, we can inject a database adapter into the object. So every service that is retrieved from the service manager, it will trigger all of the initializers. So you should only add an initializer for services that are frequently retrieved. And this is because the performance is affected. The service manager is used extensively in Zen Framework 2, so there will be an overhead if you add an initializer. Here we have an example of an initializer. We inject a database adapter into all services that implement adapter-aware interface. We call the addInitializer method on the service manager, and we pass a function which accepts two parameters. The first one is the instance that was retrieved from the service manager, and the second one is the service manager itself, such that we can use it to retrieve other dependencies. So what we do here is that we check if the instance implements the adapter-aware interface, and if so, we know that a setDBAdapter method exists on the object, and we can inject our database adapter by calling this method. And our database adapter is fetched using the service manager. So again, this is dependency injection, but you might not realize this while writing this piece of code. We also have something called aliases. An alias basically points from one service to another. So when a service with an aliased name is requested, a different name should be used instead. Now I'll give you an example. For instance, if a service A is an alias for service B, then a request for service A, it will actually return service B. So aliases can be of invocables, factories, or other aliases, and hence why they can be recursive. So you can actually have a chain of aliases. This means that a service A can be an alias for service B, which in turn can be an alias for service C, and so on. So in this scenario, requesting service A from the service manager will actually return service C. And you might wonder in which scenarios this is useful. But aliases provide a lot of flexibility because of Zen Framework's 2 modular structure in particular. An application may be using a DB adapter for database connectivity, and it can be of the type zen/db/adapter/adapter. And a module can refer directly to this key in the service manager, but if for whatever reason this is no longer the case, then a lot of references would have to be updated. For example, if we change the implementation of our database connector. Instead, if an alias was used, one could do like in the example at the bottom of the slide. So here we add an alias with the name of user_db_adapter, which points to the send/db/adapter/adapter. When we request our DB adapter from the service manager, we'll just use our alias, and it can return the actual database adapter. It should be clear that we can always change what the alias points to, and we don't need to change all of the places in our code where we refer to our database adapter. Next, there's something called shared services. Services registered with a service manager can be either shared or not shared. And in this context, the term shared refers to whether or not a new instance of a service is created on every request. If a service is shared, then if you request a service multiple times, it will always return the exact same object. Otherwise, a new instance will be created on every request. By default, services are shared, and this is for performance reasons. So each object doesn't have to be instantiated every time it's requested from the service manager. So now I'll give you an example of a shared service where we demonstrate the default behavior of the service manager. On the first line, we retrieve a user service instance from the service manager and store it in a user service 1 variable. Then we do the same on the next line, but we store the service in a user service 2 instance. If we use the SPL_object_hash function, which gives us a hash value of the object, and we compare the two hashes of the two services, we will see that these two hashes match. They are identical. And this is because the first time we call the user service, it's cached within the service manager. So the next time we request it, it's just returning the same object that was already instantiated, thus improving performance. Now I'll show you what happens if we declare a service as not shared, which is overriding the service manager's default behavior. We call the setShared method on the service manager, and the first parameter is the name of the service that we'll want to change the shared behavior of. And the second one is whether or not it should be shared, so a Boolean value. In this case, we don't want the service to be shared, so we pass in false. So if we receive the object again from the service manager, we will see that the hash values are no longer identical. And this is because the object that we fetch from the service manager is not cached anymore. So each time you request an object of this type, it will be instantiated again. That's all for the service manager. This might have sounded a little bit complex as well, but again, don't worry, we'll get back to it all. And once you get used to it, it's actually pretty simple. So, thank you very much for watching, and I'll see you in the next lesson.